So in this video, let's talk about polynomial functions. Polynomial functions, this example that I have at the top here is an example of a polynomial function. And before we start to take a look at the graph of a polynomial function, let's talk about what the parts of a function. This is a polynomial function with a degree of 5. So the degree of this function is 5. How do I know what the degree is? So what I do to find the degree of a polynomial function is I look at the terms. And I'm going to show you that this polynomial function I'm looking at has 6 terms. And I'm circling them all. Terms of a polynomial function are separated by a plus or a minus sign. So this function has 6 terms. And you look at each term and you look for the highest exponent. This term in the front, this polynomial, is sorted by descending order, meaning it goes from highest exponent to lowest. The highest exponent in the function, and it's not always in descending order, by the way, the highest exponent in the function is the degree of the polynomial. So this is a 5th degree polynomial. The leading coefficient is the coefficient on that highest exponent term. So the leading coefficient in this case would be 3. And these two things are going to tell you the characteristics of what the graph will look like. Now I want to point out that sometimes you may have something that looks like this. And if you have something that looks like this, then when you have multiple variables within a term, you have to add the exponents together. So this one would have, you would say, okay, this has a total of 8. This has a total of 5 because there's an exponent of 1 on this y, even though it's not written. This has 7, and this has an exponent total of 0. So that this would be an 8th degree. But that's not what we're going to explore today, but just so that if you do see a problem that has multiple variables within a term, you have to add the exponent powers together to find the degree. So let's go back to this one. So we were talking about polynomial functions, and we want to talk about their graphs. So what is true about polynomial functions is that if you have a polynomial function that has a degree of 2 or higher, the graph will be smooth and continuous. So by the word smooth, I mean that the graph is going to contain only round curves and no sharp edges. And by the word continuous, I mean that you're going to have no breaks and you could draw the whole graph without lifting your pencil on the rectangular coordinate system. So if this was, now I'm not saying that this is the graph up above, but if this was my xy plane and I was going to draw a graph potentially maybe of this polynomial function or maybe a different one, it would look something like this. I could draw it and it would have no breaks, no holes, continuous, and the curves are smooth, no sharp edges. So a sharp edge looks something like this. This would be a sharp edge. What does a break look like? It looks something like this, where you have like that, and maybe you have a hole here and then it continues. There's a hole there, either shown like this, or if there's a break in there, maybe it ends here and then it starts again here. So a polynomial function does not look like any of those. It looks like this. And what we're going to discuss is what this end behavior, which way does it go, and how many times does it have these curves? Like, how many curves are there? Are there just these two? Are there more? Are there less? And that's what the degree and the leading coefficient are going to help us determine. The behavior where these arrows is called the end behavior. And the end behavior is, we can find that the end behavior is to the far left, like here, and the far right, like here. And it's either, you're going to have this behavior in between where it makes these turns, these smooth curves, and then the end behavior is going to go off. It will eventually rise or fall without bound as it moves to the left or to the far right. So the sign of the leading coefficient and the degree help reveal what its end behavior will be. So again, like I said, to the far left or the far right, it's going to go off without bounds. And so let's talk about this, and we're going to summarize it in a chart. Like, I'm going to create a chart and we can summarize what I'm going to discuss. So in this first column, we're going to put the leading coefficient. So we're going to look at the leading coefficient and what it is. In the second column, we're going to look at the degree. And then here, we're going to label this the end behavior. And we're going to talk about the left side versus the right side. So if you have a leading coefficient that is positive, so I'm going to call the leading coefficient a sub n. A sub n just stands for the coefficient on the term with the highest exponent. So I'm going to say a sub n is greater than 0. Or we know that when a number is greater than 0, it means it's a positive number. If the degree is odd, so if you have a leading coefficient that's positive, and the degree is an odd degree, then the left side is going to go down, the end behavior on the left is going to go down, and the right side is going to go up. If the leading coefficient is positive and the degree is even, then both the left and the right side, the end behavior will be up. The other choice is that a sub n is negative, so it's less than 0. So when a number is less than number, it's a number that's less than 0 is a negative number. And if it has an odd degree, then the left side will go up without bounds, and the right side will go down without bounds. And if the leading coefficient is negative and the degree is even, then both sides will go down. The left and right side will go down without bounds. So this is a good chart to have and to take a look at when analyzing. So I'll pause it here so that you could take a picture of this screen or write it down in your notes. And so let's take a look at an example where we're going to reference this table and decide. So the first one we'll take a look at is the one from up above. So this one, if I look at the leading coefficient is positive. It is 3. The degree here is 5, which is an odd number. And with an odd number, then we would follow this pathway. So we're going to go to our chart I'm going to say, well, the leading coefficient was positive, so I'm going here. And the degree was 5, so that's odd. So then this should be the behavior. So if I was to look at the graph of this, I would notice that the left side went down and the right side goes up. And then in between, I'm going to have some smooth curves. I don't know how many yet because we haven't talked about that, but something like this. Left side goes down, right side goes up. What about this example? What if it says we have this polynomial function? First, you want to decide what is your degree and what is your leading coefficient. The degree here is 4. The highest exponent is 4. What is the leading coefficient? The leading coefficient is the coefficient on that term, which in this case would be 1. Even though the 1 is not written, we know there's a 1 there. So from that, I know that I have an even degree and a positive leading coefficient. So that means that I'm going to be following this pathway. Positive, even, both sides would be up. So if I was to look at this graph, and we can pull it up and take a look, both sides would be up, and they would go without bound positive. So here's my calculator, and I'm going to hit y equals, and then I'm going to put in x to the 4th minus 4x squared. And then I'm going to hit graph, and I'm going to see if I can see this graph, and I do. And I see they go the end. This is a polynomial function. We have these smooth curves. It's continuous. It goes in on the left side. It goes without bounds to positive infinity, and on the right side it goes without bounds to positive infinity also. So increases both ways, just like we thought. Now, we saw that graph had, it crossed the x-axis. And so I'm going to copy that graph to my sheet, my whiteboard here, and discuss it further. So it looks something like this, the graph. And so there are places where it crossed or touched the x-axis. There's 3 of them. And there are 2 places where it made a turn here, and then it also made a turn here. So we want to be able to examine that and see, how do we find those? So if we take a look, in order to find the zeros of the polynomial, or where it crosses the x-axis, the zeros are called the roots or the solutions. In order to find that, what you have to do is set the polynomial equal to 0 and solve for x. So this was our polynomial, and what we will do is we would set this side equal to 0, and we'll find our solution. So I'm going to pause here. I'm going to record another video that talks more about the x-intercepts, the zeros, roots, solutions, and we will discuss that further.